for the heart cell. Does that make sense? It would use glucose if needed, but the body wants the glucose to go to the brain. Okay? Does that make sense? So, technically, the heart doesn't fatigue for your lifetime. When it does fatigue, you're not going to know it. If they bring you back, well, it was like, hold up, something's wrong, need to address what's wrong. If it can be fixed, fix it. I.e., usually coronary circulation, but sometimes people can have something wrong with the valve. People can have something wrong with the conduction system. Their heartbeat's not right. Okay? Kristen?
Now when you get a heart murmur?
A heart murmur is going to be when usually the one or the other, the left or the right, AV, tricuspid or bicuspid, is not working correctly. So, there are things that can go wrong with the system. So this cardiac conduction system. It has that internal pacemaker, my sinoatrial node, and a nerve-like conduction pathway. My sinoatrial node, my bundle, the bundle of His, comes down, goes around, and gives off Purkinje fibers. What do you see those fibers doing? What are they branching into?
Valves. Muscle.
Muscle. Now, if we look at these fibers, note, comes down, turns, innervates my myocardium. I shouldn't say innervate. It projects into my myocardium as well as to my papillary muscles. And the papillary muscles are connected to my AV valve. In this case, I'm pointing to which one? Tricuspid or bicuspid? I'm pointing to my tricuspid. And they're connected. Do you remember what these fibers were called? Those little fibers that go from a papillary muscle to the little cusp of the valve, these are those chordae tendineae. And y'all should hear how the lady on the video pronounces those. I literally had to stop the video and go, what? All right, but hey, that's okay. So, that is projecting into those papillary muscles. So now, if I have the ability to, and remember, because this is autorhythmic, okay, it has the ability to start its own action potential. So right here at my sinoatrial node, which is modified heart cells, okay, the way that this will work, it will create that action potential. And we already said less than 1 second. Less than 1 second. Here's what it does. It goes from sinoatrial over to my left atria. From the sinoatrial, it will pass to my atrioventricular node. That will carry it across and begin to travel down between this interventricular septum, okay? And it will branch. This would be my point of the bundle of His, okay? And branch and go around right and left, passing that electrical potential. So it goes first sinoatrial to left atria, from sinoatrial to atrioventricular, from atrioventricular to bundle of His, from bundle of His down, around, into my Purkinje fibers, stimulating, and start all over again. In less than 1 second. And in that cycle, guess what happens? Blood does what?
Circulates.
How?
By contraction.
Why?
Because it's under pressure.
Why?
Because it's a closed system.
And it has to go what to what to what to what?
From atrium to ventricle to pulmonary vein artery, then back in. Yeah, left atrium, left ventricle, aorta.
Anybody else mind going? And guess what? What else has to circulate?
The deoxygen. The deoxygen. What else besides the blood?
What other circulation do I need to meet? The heart itself. My coronary. And we're all here sitting right now with it happen.
I have a question.
Hmm?
So where's the oxygenated blood coming? I know it'll go from like the left ventricle, right? So where I don't know where the blood flow to the heart comes from.
Meaning the coronary circulation?
Yes.
Okay. Now, we think back. All right. So, do you remember how I pointed out these two little openings right here? And based on when contraction, relaxation occurs, if it's contracting, those are not, they're I wouldn't say they're covered up, they're compressed, okay? So when the heart relaxes, they get to open up and the blood gets to circulate.
So it's like opposite of the body. Where it's going to,
Exactly.
like, okay.
It is opposite.
That's a tricuspid, right? Or no, that's a bicuspid. Where we go.
Well, that's the aortic semilunar valves.
Okay, gotcha.
So in other words, the branching for those coronary arteries is coming off of the aortic semilunar valve. Yeah.
So it's not like when the blood gets pumped out, it's not like the same red blood cell circulates around the whole entire body.
Okay, now, technically it could be, but luckily, all right, because one of the, as we learn about what's going to have to take place in the lungs, okay, now, once we get the blood flow from that right side of the heart to a lung, and so basically from that right side, when it enters into the lungs, okay, it's going to have a series of events that are going to have to take place for that red blood cell to pick up oxygen. So chances are that that one red blood cell that returned is not what's making it back to the left to start another circuit. Okay, it might be the next circuit that's coming around, because what's taking place in the lungs, which is what we're going to get to, the process that occurs in the lungs, okay, has a series of steps that the blood's going to have to go through, because we've got to make sure we drop off the CO2. But here's the thing that happens. It encounters a membrane as well as a fluid. And it's going to have to make the drop off across it and the pickup across it for the blood flow. But luckily, because of the structure of the lungs, the amount of membrane that is available based on those little alveoli, y'all ever heard of those? Okay? Because of the structure of the lungs, that is literally enough membrane equal to the size of a football field. So think about having that much membrane, blood flow coming on one side, oxygen on the other, and being able to cross. So that is a huge amount of space for this dropping off and picking up to occur. Questions? Ask me. I love the cardiac conduction system.
So, I guess my question was, like, when your heart beats, does the blood just move like a little bit and then stops for a second and then a little bit, or does it go all the way around your body?
It goes all the way around.
In one beat?
One beat. Now, remember, however, that even though that heart is beating that less than 1 second, okay, as a grand total, meaning all of that fluid, it can be like 4 to 6 liters. But you're still going to have, when that heart beats, there's still blood moving through these vessels. Okay? So it doesn't mean that when it left the heart and began the descent, for example, okay, that the next time the heart beats, that it's that piece of blood right there. It's because that heart beating, as that heart beats, in our arteries.